How has your conference been, everyone? Good so far? Yeah? Excellent, excellent. We're all ready to sleep for a week? Yeah, okay, great. Okay, so good news is the sleeping starts now because we're going to talk about authentication. So, you're welcome. All right, so session today, MSAL authentication. Auth ain't hard. It's not entirely easy though. Let's just get straight into it. I've been talking about authentication on and off for the last 5-6 years, probably longer than that. Last year, I made it my sort of goal to show you how you can do authentication with the Microsoft Authentication Library in as much PowerShell as I possibly can, just to show people that there's no magic about how this works. And I got a lot of feedback from people just saying, well, I just use the MS Graph module, or I use the Azure accounts modules to do all that sort of stuff. And I'm like, cool, but it's really important to know how this stuff works so that if for whatever reason these things fail, you at least know what's going on so that you can solve the problem yourself. Because at the end of the day, that's what we do with PowerShell. So last year I spent a lot of time talking about how much I love the MSAL library. It makes authentication really easy. You can do things in 2 lines of code. You shouldn't do them in 2 lines of code, but you can. This year I'm tweaking a little bit because I had someone at one of the conferences I spoke at, they came up to me really proudly and said, well, I don't use MSAL at all, and I use it in production code. And I turned around and said, you shouldn't do that. It's really, really bad. So what I'm going to do today is we're going to see how bad that can be and how we can protect ourselves if, in the unlikely scenario, we need to write our own authentication. Really quickly, sponsors. Thank you to the sponsors. They make the conference bearable, and we get our nice drinks and all the food and all that. I work at Patch My PC, so I'm biased. Me, at this point, I'm Ben. That's what I do. I'm an MVP in a couple of things. Azure, security, PowerShell, things. Yeah. It started off as Intune. I've got a crowd of hecklers down there, which is really good. Thank you. I'm a YAML editor at Patch My PC, which essentially means I do DevOps because once you automate everything, you spend your time in config files. So YAML editor. I should update my LinkedIn. I write occasionally blogs at my website, powers-hell.com, and I am also sometimes on social media at Blue Sky and only Blue Sky. So if anyone sends me a message on Twitter, I check it once every 6 months and just apologize. Yes, exactly. Okay, cool. And that's my professional LinkedIn photo. You're welcome. All right, so we've kind of gone over the agenda already. I'm complaining about this, or I'm talking about this in part because someone came up and was really proud that they were avoiding MSAL, and I don't think you need to avoid MSAL, but there are some problems with how it's implemented in PowerShell that I personally believe could be solved and need to be solved by the big guys, because this is such an important thing. If you get authentication wrong, you're in a lot of trouble. So we'll go into that a little bit, and then I'm going to show you how to do the incorrect things slightly better, so that you can protect yourself in the scenario that you need to do this. And then, just because I'm really, really obsessed with stuff, we're gonna talk about the new hotness, which is OIDC Identity Federation. Hands up who's played with workload identity federation stuff. Awesome. You guys are gonna all be using it after this session, I promise you. There's no credentials, no passwords, no nothing that will ever leak. It just works and it's incredible. Okay, so a quick rant. I still love MSAL. I still think it's the best way to authenticate to resources in the cloud. It works really, really well. When it is implemented, as I said, you can get an authentication token in 2 lines of code that is so easy to read that you know exactly what you're doing. So many guides out there make it seem really complicated. You've got to set up all these things, configure a billion different resources, and you just don't. It's 2 steps. The problem is kind of with PowerShell, kind of with how it's been implemented. So as I said, most people's experience is using the MS Graph modules. or the AZ accounts module to get authentication. You know, in both of those things, they're essentially just interpretations or abstractions on top of the MSAL library, because they both use MSAL. The AZ module uses Azure.identity library, which is just an abstraction layer on top of MSAL. It's all MSAL all the way down. But their implementations are a little bit weird. PowerShell has a known issue. What's Justin doing? Oh, I'll just do it for you. Full service. It's going to be great. Anyway, okay, so where was I? I was talking about the implementation. So PowerShell has got a problem that everyone knows, and it's essentially that if you have two different versions of an assembly or a library and you try to load them one after the other in the same profile, things get weird. They fail, but sometimes they fail silently, so it just doesn't work and it continues to use whatever the previous version of that library was that you were using. In the scenario of the AZ modules and the MS Graph modules, they are maintained by different teams. They cannot keep up to the same cadence as each other. So you do run into scenarios where if you need to do something in MS Graph and previously in the same session you've done something with the AZ modules, things fail. Sometimes they fail spectacularly. You get big wall of red. Sometimes they just don't work and you don't really know why. These things can be fixed, but not by us, the consumers of these modules. They need to be essentially rewritten to handle Justin, help me. The assembly load context. Thank you. Oh, of course I do. No, so the assembly load context is this a solution that it allows a workaround, but again, it needs to be written by the maintainer of this logic. What should happen, like every other library or every other language that leverages MSAL, is a single, very small module or library that does all the authentication stuff, and everything else simply inherits that. We know that we can do this in PowerShell when we create our own modules. We simply say, requires this, so it's always there. So if we could decide whether Azure Identity or MSAL is going to be the gold standard of what we want to use, it's probably Azure Identity because it is MSAL with a bunch of stuff on top. If we manage to write a native PowerShell module that implemented that and then the other first-party libraries pulled from that, we wouldn't have this problem. When you work in a language that doesn't have this problem, it's magical. It works really well. Here's Python. I don't write in Python. I asked a robot to do this. But like, what are we doing? It looks, again, I said 2 lines of code. There's significantly more than 2 lines of code. Bah! All we need to do is we create a client. That client has got all the configuration for how we're going to authenticate. And then in the result, we simply ask the client to do the thing we want to do. So in this scenario, we're acquiring a token interactively. This is the most common thing that everyone uses. This is the, you ask for a token, it opens up a browser window, you put your credentials in, it comes back, gives you a token. If we do it in Go, it's not formatted very well. I guarantee this probably doesn't run, but functionally, this is the same thing. So remove all the configuration. We're creating a client, and then we're acquiring the token interactively. Because the MSAL library is a standardized library for authentication, the naming and like the verbiage of all this is the same. So it's really easy to switch languages and know what you're working with if you understand how the library happens. Now, in PowerShell, if you want to sort of do this natively, because it's a .NET built thing, you can kind of do that. This is what I talked about last year. This is my janky, hacky PowerShell solution that is the most PowerShell way that I could do authentication leveraging MSAL so that I could show you how this works. So again, the concept here, we create the client app. It looks a little more complicated than any other language, but it's really the same thing. And then again, we acquire the token interactively. It's the same process constantly. That last command that we use, is this gonna work? Wait, yeah. That acquire token interactive, that's where you change it if you want to acquire token silently or acquire token with device code and things like that. But for demos, the interactive stuff is the shiny. There's other languages that also implement .NET that you can do this in as well. Significantly better ones, some would say that I have a preference for. You could do it in VB. You could do it in VB. I intentionally made that too small to look at because do not do this. It's a very bad idea. Functionally, that works though. You can get a token. Don't write in VB. It's very bad. That's what it stands for. Okay, so because we don't have a native module that abstracts the MSAL library in a sort of a unified way that other things can work, we know that we have these assembly load context issues. You've turned around and said, okay, well, you've convinced me I'm gonna start writing my auth libraries without using MSAL. What does that look like and how can I do it? So the first thing, again, I would say is don't. Reapproach what you're doing. Figure out how in the context of if you're jumping between AZ and MS Graph, change sessions, have two different profiles that are sort of loading these things to do that. I generally am not talking about interactive work, so that sort of, oh, something's broken, I'm gonna log in and like fix the thing or get a report for my boss or whatever. We're at a PowerShell conference, we're all tool builders here. I'm talking about building tools to do things. In those scenarios, especially small little repeatable steps, you're probably doing things like Azure Functions or runbooks or Azure Automation, whatever they call that now. So in that scenario, there's a little wiggle room where I would generally say, okay, there's scenarios where this actually does come into play, and this is where I'm gonna show you the secure, correct way to do it. Because, so take an example, my favorite way to run little bits of work in Azure is Azure Functions. They're fantastic, they're very easy to write, and they're really, really easy to come up with working solutions in PowerShell in minutes if you sort of know the APIs you're calling from. They have some problems when you want to reference or load other people's modules, in that, especially if you're using like consumption Azure Functions. From cold start, it has to pull all that stuff down. So if you go and just pull down AZ star, for example, you're going to be in a bad time. That's going to take 20 minutes sometimes to finish getting all that. Same with MS Graph. If you pull everything down, it just takes forever. So in those scenarios, having like let's call it a chiseled solution that is native and does not rely on other things, that cold start is a lot faster. So you get away with that sort of stuff. So that's a really good scenario where I would recommend if you've got something that just runs really quickly and does like one task, you could probably get away with doing that. Okay, so slides are over. Let's do this. If I can find. I think it's this one. It's definitely not name picker. All right. So the first thing we're going to do is I just want to show you what it looks like. You're all going to be familiar with like how to get a token. Who isn't familiar with how to make a request and get an authentication token? Okay. All right. Of course, Steve doesn't know. So here's an example. I left a little note for myself online too. Please read it. It's very good. I'm going to show you sort of, how you would get an auth token in using the AZ accounts module, which has sort of become my favorite. It used to be the MSAL.ps module. Rest in peace. It's no longer being maintained. It was the best way to do this because it actually surfaced the .NET libraries into a really nice way to do it. So you could actually do it the correct sort of programmatic way instead of just going, can I please have a token? It was no, create a client, request this certain thing. It's still, you can still use it. It just doesn't get the shiny new features because it's no longer being maintained, and we do not do authentication on things that aren't being maintained anymore. We do not do that, right? We're all admins, we're all adults. Some of us, anyway. Steve. Okay, so I've just got a couple of things here. I've got a tenant ID, PowerShell.com. Tenant IDs are interchangeable. I never remember my own GUID. Client ID, I've got my redirects, which is just to a local host because I'm developing a solution locally. And then I've got a couple of different scopes for examples that I'll show you later. If you were to request a token to do work in AZ accounts, it's very, very simple. Connect AZ account, tenant, application ID. That gets you into Azure. So it's essentially your identity is there. And then you're going to swap that identity out for a graph token. So essentially you're rescoping what that token is that you have. So get AZ access, resource type name, MS graph, changes simply the scope to the thing we're looking at here, graph.microsoft.com. And then we're going to add in this new one. This is an interesting one. This has just come up in the last couple of months. If you are still using the AZ accounts modules, and you will be, there's nothing wrong with that. They are adding in a change so that by default, the token comes back as a secure string, which is good. But if you do not have as secure a string in now, when that switch comes over, it's going to bite you real hard, and your workloads are going to fail. So just that's a free one for you. Add that in now to get ready for the change. Okay, so what I'm going to do is, we don't really need to see how this works. It's pretty simple, right? Let's have a look at another scenario. So that was the AZ accounts method. And this is how it's been implemented in the Microsoft.graph.authentication. It's connect mggraph, client ID, tenant ID, and then you get the mg context. So it's one line of code, but that kind of hides what the actual experience is, and you don't really get a way to directly understand what is happening, which is why I don't like it. You know, abstraction is good to a point. If it makes it so that you can't actually tell what's happening, I think it's detrimental for us at the end of the day, because as I said, if these things stop working or you can't use them for some reason and you don't know how the underlying infrastructure works, then you're kind of stuck, and then you have to learn things really quickly, and learning quickly is not fun. Okay, this is the no dependency model. There's a lot more to it. The reason I want to show this to everyone is that everything that we have to write here already exists in MSAL. So whenever you do that, can I please have a token in either AZ or the MG graph, all of this is done for you. So the first and most important thing is that you can do this just by creating a URL to get the access code and swap it for a token. If you don't have MFA set up in your environment, don't do that. Really, really insecurely. And it will give you an access token. I've talked about this previously. I jokingly called it raw dogging the internet. Oh, I'm not even going to show you how to do that anymore, but it is recorded. It's on YouTube somewhere. But the correct way to do it is to sort of leverage this PKCE method, which is a public key code exchange, which basically you generate a challenge and a verification. It's just randomized strings that are hashed out. The hashed out thing goes out to the request, and then when that comes back, you verify that you can sort of unhash the value to prove that you were the person who made the request and you were the person who should get the token. This is what PKCE is, or public key code exchange. We also previously used to have a thing called new state value, which was kind of like that, but it was literally just a word in the request that you needed to know that request word needed to match. It was less secure, but that's what we used to have. Now PKCE is the strongly recommended. So whenever you do an interactive authentication, you do PKCE for free without you even knowing. So this is how it works. I did not write this new PKCE. I absolutely stole it from someone and cleaned it up. But functionally, it creates a 43 character long thing and then returns us a code verifier and a code challenge. And then we use that code challenge to send out the requests. We use the verifier to verify that we are who we are and we should get the token. I'll have all this on GitHub. We do not need to sort of dive into the actual minutiae of this, but it's just understand it's relatively simple. And this is what sort of saves us from nightmares. Okay, the new state value is kind of the same, but we just get a value. We don't need to use it. I've just got it in my examples. What we then need to do is we need to spin up a HTTP listener to sit there and wait for that interactive auth prompt, because we're running in PowerShell. PowerShell doesn't have a browser, so it spawns an instance and we've got to wait for the responses so that we can do things. Because when we do an auth code flow, we get a code, that code comes back, and then we say, okay, I've got this code, can I please have an access token now? So we need a way to be able to catch the code in the first request and then swap it out for the thing that we need to do. It's confusing, right? Yeah, I can see you're all freaking out. So am I. Okay, so HTTP listeners is kind of neat. There's really only one thing that I want to talk about here, is this fun little thing. So normally when you do a big boy module or a big boy solution where it does interactive auth, it'll come back and like say, everything's all good, you can close this browser window. That's not really implemented very well in some of the more the community solutions that I've found. And some that I have found have done it in a really weird way. When you're building these out, you get redirect location for free when you're creating the HTTP listener. So just use that so that when it returns, you create a URL that you want to send to the screen to let the people know that what you were doing is finished. I haven't handled error handling in this, but essentially if for whatever reason that fails, you can swap the URL. Everything's on fire, this is fine. Close the browser. But I'll sort of show you how this works. Okay, finally we close, then we stop. And then I just have like my own sort of new authentication token request, which again, if we have a look here, this is my, where do we go? Okay, so remember back when I showed you the screenshots of like how this works and it's 2 lines of code? This is the first thing. So this is our auth context. And then the second thing is once we have that auth context, we're gonna invoke a REST method, we're gonna send that back out and say, give me my access token. Okay, we're all following along, this is fantastic. We can wrap that all up in a simple little solution called new auth token request, and then we get our token. So let's load some things up and see this fail, so I can show you what I did wrong. So for context, what we're talking about is the intern at work has been told to create a web app solution. So they created one, you set up the app registration, you set up a single page SPA redirect for local host so that they could dev, and this is what's gonna happen. Okay, just load this in. Load all my functions in. Okay. All right. So this has immediately prompted me with a browser window asking me to sign in. So I'm just going to go ahead and select my account. Access granted. Fantastic. We're all happy. I really like this. Go get yourself a treat for being so smart. When you get back, you can close this window. Okay. So we can close that because we're so happy. Everything worked. And then if I can find this one here. Let's have a look at what is in Auth. It actually worked. That's hilarious. Let me try that again. I'll just clear this out. We got it in Auth. Okay. Why did you decide to do the Auth dance this session, Ben? Okay. Okay, apparently ignore me. Maybe I fixed it in my sleep. What I was going to show you, and I can still show you in the actual portal, because this absolutely shouldn't be working, is that because we had localhost pinned to the redirect of an SPA, and we're trying to do things in terminal, things get weird because localhost can only be used once in a context, and there's a couple of different contexts that you can use it for. The solution to that is to add a specific end to the localhost command. So in this scenario, it's probably why it's not working. Hang on, I'm just going to do this. No, I'm just going to close this one, so we don't need to see that. Okay. If we have a look here, I've probably done this. So the redirect URI that I've got here, so it says 5001/app. So when you create your redirects, you don't need to put the port number in, but what happens is it uses the last bit of the redirect to create it as a unique entry. So you can have as many local hosts as you want as long as you add something to the end. So that's how you get around a scenario where an app registration is being used for more than just one thing. So like, when we want to do automation things against a production environment that is already using localhost for like web dev stuff, this is the solution. And I'll show you in the portal now. Go into Enter ID, app registrations. Cool. Oh, it's because I've already got it set up. Okay, so we can see, like, this is the scenario. You definitely can. How's that? I'll just do this. Okay, so the single page application was localhost. That was for our web devs to like test things locally. I've already fixed it and I forgot to break it again for my hilarious joke to land, but that's fine. The mobile and desktop applications is what we use for command line things. So the solution is to add localhost/app. So the important thing is to note, I don't have the port number there. The port number is considered a wildcard value in authentication. They understand, especially if you're using the word localhost, that you're working in a development environment, that port number is going to change all the time. So it just does, it's not part of the authentication flow. This only works for localhost. But this is how you get around with that. I just want to show you, this is very important. It took me a little while to figure that out. The other thing about the port number, when you use the example that I showed you with the HTTP listener, if you put a port number in the redirect URI, when the HTTP listener spins up, it spins up and it's on that port number. So the redirect knows to, that's going to be what it catches on. So it's, again, you get all that for free. I think it's kind of neat. Okay, so that's the example that I've got for authentication. What I wanted to show you is a scenario. So, if I really quickly look at, how am I going for time? 127. All right, nice. So I had two scopes in there because I wanted to show you what happened when you just requested graph.microsoft.com default. Also, I'm just going to quickly stop. Does everyone know that this scope, this is a magic scope that gets you all of the graph permissions in an app registration that you've got? Yeah? So instead of specifically saying, well, I need users, devices, whatever, you can just say, well, my app registration has got all these things and I need them, so can I please just use the defaults? And that gets you that back. So I'm just going to change this a little bit because what I got here is I got an access token, right? But I got nothing else. Maybe I'm in a scenario where I need to get my ID token, or maybe there's no reason in the world that you need this, you need the refresh token as well. Well, now because we're not using MSAL, which protects you from yourself and hides the refresh token for you, because we're not using MSAL, we can do really dumb things. So I've added a couple more scopes to my request. I've got OpenID, profile, and offline access. Offline access is the magical thing that when you add that into your scope, you get a refresh token. Does everyone know why refresh tokens are bad?
Because you could just copy the entire thing and replay it.
Correct. So the crowd answer was refresh tokens last a lot longer than an access token. So an access token is generally, from a couple of minutes to an hour. A refresh token can last multiple days. That's really bad if that leaks, because someone can just keep replaying that and keep getting a token and they can continue doing bad things in your environment. So don't ever do what Donnie doesn't do, okay? All right, so let's load that in. Okay, let's do this. Working on conference Zoom is horrifying. No. No, because I don't need anyone screenshotting and copying my refresh tokens. Thank you very much. I bet you do. Okay, I'm going to do this auth flow again. Access granted. I love this lady. Okay. All right. So what do we got now if we look at auth? We've got a lot more going on. I'm just going to bring this up. So we can see here we've got an access token, we've got a refresh token, and we've got an ID token. Generally, you never really need to use the ID token. I've come into like real world scenarios where you do. There's a thing called Easy Auth that you can use in Azure. It needs the ID token because it's a lazy, loady sort of like solution. But by default, when you use AZ Identity or MS Graph, you cannot get the ID token. It's kind of a pain in the ass. So this is where I end up having to sort of roll my own solution for this sort of thing. Again, the refresh token should never be used. You should never store this. MSAL looks after it for you and makes sure it's never actually stored or cached on the device after your session is closed. And that, again, is why always use MSAL. Okay? Is there any questions at all? Thank you, that's beautiful. Okay, nice. My crowd is full of lovely, supportive people.
Looks like I've got power.
Very good. Okay, so before I go into the next things, I'm going to do these really quickly so I can show you the new hotness. Does anyone have any questions on that, or are you all exhausted and confused? Because it's okay. So am I. Okay, fantastic. So I'm just going to really quickly show you the next ones because where I sort of suggest that this scenario is in use is in the non-interactive way. So like system-based things that just run on a cron job or they're automated. So function apps, runbooks. So the actual flow for this is a lot simpler because it is meant to be a little bit more secure by standards because it is supposed to be run in the background. So client secret is a really common one. We've just got a tenant ID, a client secret, and a scope. The AZ accounts method is to create a credential object and then simply use connect AZ account, service principal, credential, put your credentials in and your tenant ID, and then you just get back an access token. Okay, this is the most common. This is still kind of what I use whenever I'm building out function apps to test locally. Hopefully everyone sees where the problem is. You have to put your client secret kind of in plain text or somewhere within the application so that you can retrieve it. And that's where credential leakage comes into play. And that's why I don't really like this solution. This can be swapped out for certificate-based authentication as well. But the same thing applies. There is a potential that that could be leaked as well. So this is why I generally don't like this solution. The no dependency method of this is actually really, really simple because you don't have to do that two-step process. You don't need to ask for a code and then get a token because you've got a client secret, so you can just interact with it. So what we're doing here is we're just hitting the token endpoint, which is right there. So Auth2 token. And then we're just putting in some information. So the client ID, the client secret, what scope we want. And then we're saying, hey, this auth request is a client credentials flow. So it just knows that it's, okay, cool, you're doing like service principal authentication. We invoke that, we get an access token back, we do the things we need to do. The access token has the same lifespan as an interactive thing, it's just this is how it's done for non-interactive things. We don't need to see this in action, it's the exact same boring auth dance, but it doesn't pop up a browser window because you don't need a browser window. It's in a back-end system somewhere. Device code flow is a little more exciting. We can do this one. I'm just gonna load these in. Okay, the AZ accounts way of doing this is to go connect AZ account tenant, application ID, and then just a flag that says use device authentication. So device authentication is a way that it sends you a code, and then you go to a browser, put that code in, and then do the auth dance, and it sends it back. This is normally used in scenarios for things like kiosks or devices that don't have a keyboard that need authentication. So the code will run, it'll give you a code, and then you go to a thing with a keyboard, do the auth dance, and it comes back. The most common things like this are TVs. When you sign into like Netflix or whatever, and it just gives you a PIN, that's device code flow, because obviously TVs don't have keyboards. I'm sure they do, mine does. Anyway, so cool. The no dependency method is a little more complicated. So we've got our authorization parameters. Let me just load these while I'm talking. Oh, actually I can't, I need to run the whole thing. So let's have a quick look. So device code, we're gonna hit a request for that code. I've seen some horrifying implementations of this where people are like trying to pass like strings and all that sort of stuff. You can just get it. If you use invoke REST method, the response comes back with a user code. You can just throw that in your clipboard and then the next step is there. It's already in the clipboard for you. We're gonna open a browser window, you hit paste, do the auth dance, and we're on our way. So let's just run the whole thing. I even have error handling in this one because that's how professional I am. Okay, let's do. Okay, if we go in here, command me. So that's our code. And then we do the dance. Are you trying to sign in? So it's good in the way that it's like, hey, do you know what you're trying to do? Do you know what this app is? Yeah, I think I do. Justin's probably broken it, but let's just see. Cool. So PowerShell Summit 2025. So this, what we're looking at here, this app verify, that's doing that redirect thing that I showed you in the first thing. This is just more official, significantly less cool than mine, but it is a thing. Okay, so now that we've got that, we're gonna get a token. The result of this stuff, dictionary, no thank you. Ugh. The result of this stuff is a lot less exciting than the actual thing, but we have an access token now. Cool, we can now do our workloads. This again it's still interactive, so you can't use this in like an Azure function because what are you gonna do with the code? Like you still need to interactively do it, but I thought it's worth pointing out. Okay, I think we're running kind of behind. So I'm just gonna really quickly go into the managed identity flow. So this is the new hotness that I wanna talk about. So when I said that client secret or client certificate was not my recommended way, that's because I and almost everyone have accidentally stored a client secret in source code, put it into a repository, and then you're just like, computers were a mistake, right? So to stop that, the solution is to just not use secrets. Don't put things in app registrations that could leak. We do that with, does everyone know what managed identities are? Not enough of you. Managed identities are simply a service principal app registration that has a certificate-based authentication that is managed and rotated by Microsoft, so you don't need to think about it, pinned to a resource, so you automatically get an identity token and then you can request an access token and do the things you need to do. So this allows you to just get a token without having to care what the password or the certificate is, because it's managed for you. If you're using system-based managed identities, they are tied to the lifecycle of the resource or resource group. So if you delete that resource group, that managed identity is gone forever. If you do a user-based one, that is where you can use it across multiple resources. I would say that system-assigned ones are a little more secure because if you feel like you've been compromised, you can just kill the resource and it's going to go away really quickly. But they both intrinsically do the same thing. So what I found out recently is, so Microsoft has just really leaned in heavily with this concept of open identity or OIDC. So OIDC allows us now to say, instead of a human, this workload has a way to prove that it is who it is, so we can now trust it, so we can start doing work and get tokens instead of having a user. So what they've done is they've now said, well, managed identities have a way to do this OIDC flow to say, yes, I am who I am, which means that we can set up authentication. Okay? We can use an app registration, link it to the managed identity, and then we can get all the things we need to do in Graph. There is a way to do this without that. You can just create the managed identity and like hack in some Graph API permissions. Don't do that. It's generally not recommended. You can't do it in the UI. I have code to do it. Don't do what I do. Do it this way. So I'm just going to show you, how am I going to show you? Let's have a look here. This is all shiny new. I wrote a blog post about this recently, so I should know more about it. I'm in the device code flow. Let's look at this one. Okay, so the AZ account way of working with managed identities is, so first you go into your resource and you say, I would like to use an identity. That creates it for you. Cool. It injects a bunch of environment variables in the thing that you're working in. In this scenario, we're looking for an MSI secret, which is just a managed system identity secret. We then get the AZ access token using, where am I? Somewhere. Yep, so get AZ access token, resource URL. This resource URL is really important. This is the token exchange. This sets it up so it knows you're about to bounce off and do the workload identity federation. And then finally, so once we've got that identity loaded and we've got a token with the correct resource URL, we then connect AZ account, tenant, application ID, and then federated token. What this does is it grabs the token that we just created and then uses that to sort of jump onto the next app registration and do work. I know this is confusing. I can talk about this for a very long time, but I don't have a lot of time. So once we've got that, we then get access token. We do the things we need to do. The cool thing about this is we've now got a secure app registration with no physical way of using a password or a certificate. The only way to use this is to use a managed identity. And that managed identity is tied to a workload that you protect in Azure. So it's kind of cool. Okay. Thank you. I'm excited. Listen, authentication's exciting. Okay. This is kind of how you do it. I'm not even going to go into it because it's complicated. Again, I did write a blog post on this and I broke it down exactly what each thing is doing. I just want to show you it in action because it is 1:42 and I think this is a 45-minute session. Okay, so over here, I'm just going to refresh this and log back in. This is a different tenant than my PowerShell tenant that my good friend Bjorn gave me access to because I no longer have access to the intern training tenant. The intern got fired. I tried nothing. Okay, so in here I have an Azure function. I'll make this a little bigger. Okay, we've got my function app. Let's go into this one. Okay. I'm going to do this quickly. Who hasn't created a function app and played around with function apps before? Okay, so if you want to know how this actually works, come and find me and I'll take you through a step-by-step process, but I'm just going to do it quickly. So system assigned, we turn this on. That creates the managed identity for you. You never need to think about it again. This is the object or not the client ID, but the ID of the managed identity. So we need to know what this is. And then we go ahead and we just write our code. We link it to our app registration. If I go into home, enter ID. See if I can remember what I called everything. Yeah, this looks good. Okay, so this is my app registration. What I'm going to show you is even stupider than this flow. This is a multi-tenant app registration. I've registered this app in my personal tenant. There's no passwords on this. I'm going to use a managed identity in tenant B to get access to resources in tenant A without any credentials. It's kind of horrifying. This is what we can do now. Okay, let's go into authentication. Nope, we're going to go into certificates and secrets. So we have no certificates. We have no secrets. We have a federated credential. This is our workflow auth demo. So the object ID of the managed identity that we had previously, we've chucked that in here. We have an issuer. This is an official issuer that you use for all of these workload identity things against apps. So it's just login.microsoftonline.com and then your tenant ID of the main tenant that is going to be doing these things. Okay, v2.0, we put that in. Our audience is automatically filled in for us. So this is that magic thing that I showed very briefly. But all you need to do is put in the URL and that object ID, hit update, and it's linked. Like, it's so easy. So, all right, once we've got that set up, we're going to go back to the function app. If I can find it. Oh, they've changed everything. Okay. So here's my example that we're going through. So again, I don't have any secrets stored anywhere in this thing. I'm leveraging the managed identity to swap the things over. What I want to do is I want to just see what devices I have in my customers tenant or PowerShell. So I'm just going to test it. I've created it so that I have to put in my customer's tenant ID in the parameter. So I can now use this to like manage all of my devices from one function app. So if I need to do reporting or whatever, I can use this concept, just swap out the tenant ID and get all that data. So this is my personal tenant ID. I'm going to go ahead and hit run. And this is going to take a little while because it's probably gone to sleep. Or it'll fail. We'll find out. All right, 200 okay. We've got a mess of stuff that we can't really see. Let's pop over here. I got a lot of data back about all the devices in my personal tenant. It's pretty exciting. So functionally, what you can do with this now is anything that you want to do with the AZ API key, API permissions or graph, you can now do in a secure way across multiple tenants without ever having to worry about slipping and leaving those secrets in your code. So local development gets a little tricky with this because the managed identity only lives in Azure. Justin has got an interesting solution that allows us to mimic this in a way locally so that you can actually develop without having extra logic for your authentication locally, which I'll provide a link for. Justin.
You can also just use Azure.
So
You can also use Azure Arc. This is a huge benefit, better security.
So, okay, yes, the Azure Arc thing is good. There used to be concerns about having your local machine connected to Azure Arc. Realistically, you probably shouldn't be developing directly connected to Azure. You should be doing this locally and deploying it because you know your code's perfect and everything just works, but we don't live in that world, so yeah, chaos. One other thing I want to point out, this might not be the right audience for this, but this logic works in Kubernetes as well. So you can actually pin this directly to just one pod that does the work in all your customer environments in the most secure way possible because it can only run here, it cannot run anywhere else. I am genuinely excited about this way of working. Federated credentials can be used in GitHub, Azure DevOps, basically anything that is implemented OIDC, which is almost everything these days. If you can link it or figure out what the OIDC connection strings are, you can set this up so that you can just get access to Azure without having to store secrets. So I use it all the time in Azure DevOps to do deployment workload stuff. For PS App Deploy Toolkit, for anyone who was in the last session, I set up a way for us to do code signing on their new module against a code signing certificate in a key vault in our tenant without any passwords, but it is super secure. So they can just do whatever they need to do and it just works. Okay, I don't think we've got time for any questions, but come and hang out and ask questions. Thank you.